Hello, class. This second of the recorded lectures for section 5.2, which talks about graphing in the polar coordinate system. So what we talked about in the first recorded lecture was graphing circles. We started with just r equals a value, and then we went into taking a look at r equals cosine of theta times a number or sine of theta times a number. And now we're going to take it and show you a couple other shapes. These shapes are quite challenging to do by hand. And the strategy is typically the same, where say like we have, let's see which one I'm picking this one again, where I use cosine of theta. And so this one's a little bit different. It's not exactly a nice circle, because now we're adding this kind of +2 involved with the whole equation as well. And so when you walk through these calculations, again, same strategy if you're doing it by hand. You'll set up a table of theta and output values of r and see what you get. So one of the things that you'll realize at the beginning here, right, is that what's nice about this one, and let me just pick a couple values to kind of show you. And so if we had theta, right, and then the output of r, which is 2 plus 2 cosine of theta. Let me just get a couple values first, and then we'll start plotting them. So when when theta equals 0, 2 plus 2 is 4, right? Because cosine of 0 is 1. And again, I'm going to skip the 30 degrees and just do 45. So here you would get 2, and then it would be plus 2 times what? Square root of 2 over 2. So you see it's getting a little bit smaller. So this would be 2 plus square root of 2, and that's about 3.14. And so 90 degrees would just be 2, because cosine of 90 is 0. And so 135 is 2 minus square root of 2. And you'll see 180 is 2 minus 2, which will give us 0. Remember, cosine of 180 is minus 2, or minus 1, excuse me. Minus 1 times 2 is minus 2. So let's take a look at what we have here if we just start the graph. So and we have to go all the way to 4. So let me get 4 of these on here. That actually is not too bad if I do say so myself. And so if we put these in red, so the 0, 4 would look right here. And so 45 would be 2 square root of 2, which is 3.4. So it'd be somewhere about right there. And then 90 would be 2, would be somewhere right here. So this would be 2 minus 1.4. So that's going to get about right. It's less than 1, so it's going to be right here. And then at 180, we can end to 0. So if you see this thing, it would be graphing like that. So, not the greatest, right? Well, what ends up happening here is that if you keep going, and say if you go to 225, that would be 2 minus the square root of 2 again. And then if you went to 270, you would see that would be 2 plus 0 again. So we go back to 2. And then 315 and back to the start, 360, this would be 4. And since we're in the fourth quadrant here, this becomes positive again. So it looks like that. So when you're going back out, you'll see that when you come to 225, it comes about right there. And then when you hit 270, you get back to 2. And then at 315, you're back about right here, and you end up back there. So it kind of looks like this. That actually isn't too bad. And with regards to that particular graph, they call that a cartoid. And if you looked on the slides, you would see a much nicer looking graph. As you can see here, this would be what a cartoid is looks like. And so if you take a look at these equations, these are the equations of a cartoid. And as we continue to make things more complicated, here's another fun equation. And that's what's called a four-leaf rose. And that equation is r equals cosine of 2 times theta. And so one of the things that you want to starting to get familiar with is being able to use technology to do some of these. So again, Desmos. And so what was the first equation we did? R equals 2, whoops, that's 3, plus 2 cosine of theta. Not E there, sorry. Here we go. There we go. So you can see that was theoretically the equation that I was trying to show you before. And here's one that has the four-leaf clover. And this was cosine of 2 theta. Spell theta right. And you can see here's our little four-leaf clover. What happens if it's 3 theta? R equals cosine of 3 times theta. And you can see now, instead of having 4, we only have 3. So what's kind of weird is that the odd numbers give you different leaves than the even numbers do. And the only way to kind of prove that is to walk through the same type of analysis that I showed you before and just keep plugging in values of theta. And so again, this is the, let me make this a little bit smaller. So this is the four-leaf clover. And you could see that here, n number of leaves if n is odd, and 2n number of leaves if n is even. So you see that that's what ends up happening in these calculations. So you'll see that using a device, using Desmos or some sort of help with these graphs will be very useful. I mean, to try to do something like that would be almost impossible without a little bit of technology. You can see this is r equals sine of theta plus sine cubed of 5 theta over 2. But you can see how these equations are nice with regards to curvy lines, right? And so you'll see, and I'll let you take a look at this in either in the book or in the presentations here, a variety of different styles of graphs. So this will end the second, the recorded, excuse me, wow. There we go. The recorded lectures for 5.2, which is graphing polar equations in the polar coordinate system. We'll do one more lecture and it's going to talk about symmetry.